This last one is a little intimidating. It looks like there's going to be a chain rule and a quotient rule, and I got a square root in there, so there's lots of things happening. Let's just take it piece by piece. On the left-hand side, we're going to have to use the quotient rule. Remember that's low d high minus high d low. So low d high. So we got to take the derivative of this sine 2x. That's where we're going to have to use the chain rule because we got 2x inside of the sine. So take the derivative of the outside first. Derivative of sine is cosine. And then the derivative of the inside, 2x, is 2 dx. So that's low d high minus high d low. Be ey dy. Over the square of what's below. Ey squared. On the right-hand side, we have that square root of y, which is y to the 1/2, and we can use power rule, 1/2 y to the negative 1/2 dy. That's all of the calculus that we have to do. Now it's just about simplifying and rearranging this equation so we get it to say dy dx. So look down the road a little bit. We're pretty good at solving equations and simplifying things and making this easier for us. And what I notice, first of all, is in my numerator here, both terms have an e to the y that can cancel with one of them down here. So what I'm going to do is factor out that e to the y, and we'll be left with 2 cosine of 2x dx minus sine of 2x dy. All of that's going to get divided by e to the y squared, which is e to the y times e to the y. On my right-hand side, we might think it's easier with the powers in there, but it really does look like a mess. So I can handle that y to the negative 1/2. Negative puts in the denominator, and the 1/2 means it's a square root of y dy. Now, like I said, on the left-hand side, this e to the y will cancel with one of these. And we're left with a nice little fraction, but it's still a fraction. We can easily get rid of a fraction by multiplying both sides by e to the y. That'll get this to cancel on the left and bring it over to the right. So what we're left with, 2 cosine of 2x dx minus sine of 2x dy. On the right, we'll have e to the y over 2 square root y dy. Now we can collect all the dy's on one side, all the dx's on the other, so I'll leave 2 cosine of 2x dx over here, and I'll add that sine 2x dy over to the other side. That will leave me with e to the y over 2 square root y plus sine of 2x, and both of those are my dy terms, so I factor out that dy. Now, we can get our last step going. I want to have dy dx, so I divide by dx on both sides, which means I have to divide by e to the y over 2 square root y plus sine of 2x to get rid of that. That's the same as, dividing by a fraction is the same as multiplying by its reciprocal. So what I'm going to do is, here, I'll write this out, show my work properly. Okay. Then what we'll have is 2 cosine of 2x times, and I want to write this denominator as the reciprocal of one fraction. So to make it one fraction, I would have to multiply the second term by 2 root y over 2 root y. So my denominator would be 2 root y. The reciprocal of that would put it in the numerator, 2 root y. And my denominator would be e to the y plus 2 root y times the sine of 2x. And that's my dy dx. Now, there's not any canceling or anything that we can do with that. So if you want to just simplify, clean up a little bit, Put that 2 cosine 2x in the numerator, and we left with 4 square root y cosine of 2x over this big ugly denominator, e to the y, plus 2 root y sine of 2x. And there's our solution.